Next, we are going to look at the graphical interpretation of system of equations. For example, linear system could also have unique solution, no solution, or infinitely many solutions. We will look at every case's graphical representation and introduce important terms such as slope and intersection. We'll start with system of unique solution. Let's say we have this system of two linear equations. And we can solve this equation by using addition methods and get a unique solution. So we can multiply the second equation by 5, which will give us the following equation: 10x plus 5y equals to 35. So this is a second equation. And then we can add them. By adding them, we will get rid of 5y. So adding these two equations will give us 13x equals to 39. And x will be equal to 3. And if we take, for example, the very first equation and put the x here, it will be 3 multiplied by 3 minus 5y equals to 4. And here we'll have 9 minus 5y equals to 4. Minus 5y equals to 4 minus 9, which is minus 5. And we will get y equals to 1. So our solution set will be 3 and 1. So how does the system and this solution looks graphically? So every linear equation, as we mentioned previous chapters, is a line. And system of two linear equations are two lines, and point where they intersect is our solution. For example, here 3x minus 5y equals to 4. And this one is 2x plus y equals to 7. And as you may see, the intersection lies just where y is equals to 1 and x is equal to 3. The slope of a line is a measure of how fast it's changing. So to see the slope, we can solve both of equations for y. So if we take the first equation here, this one, and solve it for y, we will get 3 divided by 5x minus 4 divided by 5. And then we do the same for the second equation. Here we don't have to, so that will just give us minus 2x plus 7. Our slope is here. So as you can see here, slopes are different and two lines intersect in our unique solution. So let's move on to the next example. The next example is unsolvable systems. Some systems do not have solution, like the following. We can divide this equation by 2. We will get minus 2x minus y equals to minus 4. And we leave the second equation as it is. 2x plus y equals to 7. So I will also write them down here so we don't mix them up. Here now we can just add first and second. By adding them together, we will end up having 0 here because we just eliminated all our variables. And here we will have 3. So what it means? So we know that 0 cannot be equal to 3. Thus, this system of equation has no solution. But how it looks graphically? So if the solution set is empty, so you would understand better, it means that these two lines are parallel. And if you know that from geometry, from high school geometry, that two parallel lines can never intersect. Thus, the solution set is empty. So this is our first equation and this is our second. So they are just parallel and they will just never intersect with each other. And if we want to look at the slopes of these two equations, so let's solve first and second equation for variable y. So here we will have y. So we will first have to divide every element by -2 and then move them on the other side. So we will end up with something like -2x plus 4. And for the second equation, we will just move 2x to the other side. Will give us the following -2x plus 7. And if we look at the slopes of this equation, you see that they are similar. Just y-intercept is different. Thus, they are parallel. They just intercept with y on different points, but the slope is the same. All right, and let's move finally to the last example, system with infinitely many solutions. So some systems can have infinitely many solutions, like following. So let's try to solve this system. Again, the easiest way is just to solve by using addition elimination method. So here we can either divide the first or multiply the second one. Okay, we can do it like this. So we multiply the second equation by 2. So we will leave the first equation as it is. -2y minus 14. And here we'll have 4x plus 2y equals to 14. And now we will just add them up, first plus second. It will give us the following. We will have 0 here and 0 here and also 0 here. So, interesting. We have 0. So if you remember on the previous example, we had like 0 equals to 3, which was also, in this case, the solution set is empty. But here, both sides are equal and both sides are equal to 0. What does it mean? So what does it mean? It means that one of the two equations is redundant and unnecessary, and it can be removed, either first or the second one. So we can remove one of them and solve for y. Let's take the second one since it's easier to solve for y. We don't have to do any manipulation. So we just take this one and we will solve it for y. So y is equal to 7 minus 2x. It means that solution set will be the following. Solution set will include x, and also instead of y, we just write this one here for all real numbers. It means that all real numbers that satisfy this pair will be our solution set. So if we look graphically, both of these equations are identical. Let's look at the slopes as we did on the first two examples as well. So the slope for the first equation will be, so we divide everything by -2 here. And here we will have -2x plus 7. And here we will just move -2x plus 7. Not only slopes are similar here, but also the y-intercept is similar. So both equations coincide with each other. Thus we can have infinitely many solutions for this system of linear equations. So we are moving for the very interesting part of our topic for today, which is Gaussian elimination.